Applications of probability, and what we're going to do today is describe events. Alright, events are just outcomes or groups of outcomes inside of an experiment. So in example 1, we have some students were asked what pets they have at home. The following table shows the results of the survey with the students identified by numbers. Alright, so we have students identified by numbers. They could have names, but in this chart they are just numbers, student 1 through 10. The survey is the experiment being done. Alright, and that's already been done, so sometimes you have to do the experiment yourself if it's like coins or cards or anything. And then we have a student is chosen from the group at random. Consider the following events. D, the student has a dog. C, the student has a cat. B, the student has a bird. F, the student has a fish. And H, the student has a hamster. Now, if you notice, all the events start with the letter of the animal. Alright, so sometimes math actually wants to make your life easy, which is crazy, and you can remember that now. D's dog, C's cat, B's bird, F is fish, and H is hamster. So we want to describe each of the following events by listing outcomes. First one we have is just event C. Event C, you're going to start off with just put in C equals. The next thing is, people think you have to use parentheses, but actually you're going to use these brackets. Alright, you can just do like squiggly lines, not to be perfect, but like those like brackets that you see on the keyboard, so not parentheses, brackets. And then we're going to list the outcomes, the possible outcomes of the event C. And if we look at C, C is a student has a cat. We look up at the chart. We have student 2, student 7, student 9, and 10 all have a cat. So we are going to write those numbers. We got 2, we got 7, we got 9, and we have 10. And then we're going to close it with the bracket. And that's what we do. We just described the event by listing the possible outcomes of if a student was chosen at random, what students would have a cat, and it's student 2, 7, 9, and 10. Alright, the next one, we get a little different here. We have event D, which student has a dog. We have this little symbol here, and then we have event B, which is bird. This symbol right here is actually mean an intersection. Alright, I'm going to write it over here to the side. This means intersection. And intersection, the way you pronounce that is you just say the word end. Alright, so what we have is event D, N, event B. And when you think of N, it means both. We want everything. So we want whatever we put down in this list of outcomes. I'm going to put my bracket. This student needs to have a dog and a bird. Alright, dog and a bird. So let's look here. Student 2 has a dog, but no bird. Student 4 has a dog, no bird. Student 7 has a dog and a bird. Student 10 has a dog, but there's no bird. It's a blank spot here. So our actual only outcome here is student 7. Alright, so student 7, I gotta erase this. Student 7 has a dog or a bird. Alright, let me erase this marks. Alright, cool. Next one we have is H, so event H, which is hamster. Then we have the same symbol, but it's actually flipped upside down. And then we have event F. This symbol, which I'll put over here, it's like a U, means union, which is easy to remember because what's union start with? The letter U. And what you would say with the U is the word or. So in this event, we want to know what student has a hamster or a fish. And they can have both, because or is either one or both. It's got to be one or the other, and that's fine. So let's look at the students that have a hamster or a fish. So I see student 5 has a hamster, and I'm going to go over to the fish column, and I see student 5 has a fish, and student 6 has a fish. So the possible outcomes are 5 and 6. We don't need to write 5 twice, because are there 2 student 5s? Alright, think about it. If you have a hamster and a fish, are there 2 of you that own a hamster and a fish? No, there's just 1 of you. So you write the number 5 once because it's only 1 student. They're not double. You can't have more than 1 person of the same person. Alright, the next one we have Event B, which is student has a bird, and then we have the symbol above it. This bar, there's a line above it. And what that line is, I'm going to squeeze it all the way over here, what that means is complement. With the E in there. And complement basically means everything else. So we actually want to list in our event here everything else that isn't event B. Event B, we have the student has a bird. So we're gonna list everyone that doesn't have a bird. And what I see here is it's good to identify the event and then go to the opposite. So we have bird, which is right here, and we have student 7 and student 9 have a bird. So we're going to write everyone but 7 and 9. So we have 1, 2, 3, 4, 5, 6, and we're not going to write 7, so we got to skip to 8, no 9, and then 10. Alright, that's the all the possible outcomes of event complement of B. So everything else but B. Alright, next one we have, again, the complement symbol, but it's actually above D, and remember that's intersection, so it's D, event D, which is dog, and event C, which is cat. And then that line above it is saying we want everything else that isn't a dog, that a student doesn't have a dog and a cat. So we're going to find the students that have a dog and a cat, and it looks like student 2 has a dog and a cat, and student 7 has a dog and a cat. So we are not going to write those numbers down because that line above tells us we want everything else. So when we write in here, we're going to write 1, not going to write 2, we're going to write 3, 4, 5, 6, 8, 9, and 10. So these are pretty big lists. Alright, student 2, student 7 had both dog and a cat. And, oh, actually student 10 too. Look at this. Missed one. Alright, so student 10 as well. So we're going to go back and we're going to erase that. Fix it up. Alright. There you go. So student 10 was included, so we're not going to write it because we want everything else but. And our last one here, I'm going to erase this real quick. We have that U-shaped symbol. So we have event D, so the student has a dog, or event C, which is the student has a cat, and we want everything else, so we don't want the students that fall in this category. Alright, so student has a dog or a cat. So we can use the same ones we did in the dog and cat, because they're going to have one or the other. So we have student 2 has a dog or a cat. We have student 4 has a dog, no cat. Student 7 has a dog and a cat. Student 9 has a cat. And student 10 has a dog and a cat. Alright, so we're going to put in here all the ones I didn't circle. So we have 1, 3, 5, 6, and 8. Alright, so student 1, 3, 5, 6, and 8 all do not have a dog or a cat. They have some other animals or no animals. And that's how you list the outcomes of these events. Alright, so intersection is the U-shaped symbol but upside down. It looks like an N, but it's not really an N. It looks like it might be a rainbow as well. And you pronounce it by saying end. So you would say event D and event B, which includes both of them. And then union is or, so they just have to have one or the other. And if they have both, then that's fine, whatever. It still had one or the other. And then you just include it. And then the complement is the bar or the line above it, and it just means you want everything else. When you write down the outcomes, you want everything else that it would be part of the event. Alright, example 2. Hector has entered the following names in the contact list of his new cell phone. Alicia, Brysa, Steve, Don, and Ellis. He chooses one of the names at random to call. Consider the following events. Event B, the name begins with a vowel. And event E, the name ends with a vowel. Alright, so now we have event B because it begins, so they're matching up the B with begins, and E matches up with ends, so that's going to make our life easy. What we're going to do is we're going to draw a Venn diagram to show the sample space. Okay, the sample space is all the possible outcomes. So it's going to be all their names, and we're going to put it in the sample space. And events B and E. Then describe each of the following events. So the second part of this, the one I'm circling right now, is what we did in the first example. So if I run out of time, you guys can do that yourselves, but I'm going to do the Venn diagram for you right now. So a Venn diagram, we all know what this looks like. If you don't, it is two circles like this. And we're going to add something to this. In probability, we need to put a box around our two circles. Because if someone doesn't fall into this Venn diagram, they're going to be outside in the box. So we have event B, so I'm going to label this circle event B. And we're going to have event E, so I'm going to label this circle as event E. Alright? And there could be more than two events, but we're going to deal mainly with two events, so you just have to do two circles. Alright, event B is the name begins with a vowel. Let's look at our names here. So I'm going to put every student that begins with a vowel in the B circle. So we have Alicia, and we have Ellis. And then E is going to be the names that end with a vowel. We have Alicia again, so we're going to have to fix that. We have Brysa, and we have Steve. Okay, Alicia's in both of them. This middle section right here is the intersection. That means when they fall in both categories, they'll go in the middle. So we're going to take Alicia's name out of there, out of B and E. And we're going to put her name in the middle because she fell into both categories. She had both event B and event E. So Alicia's going to go in the middle. And we used everybody's name except one person, and that was Don. So Don's name is going to go out on the outside because he's actually not part of these events. And that's how you make a Venn diagram. And from here, now we can describe the events a little bit easier. Because event B, I'm going to put it over here, event B equals bracket sign, every name that's inside the circle B, which is Ellis and Alicia. I'm going to close that. I squeezed it in there. Event E, we have Brysa, we have Steve, and we have Alicia, because she also ends in a vowel as well. So Alicia's in both categories. And then the next one, we have the intersection of B and E. So this is where the person, in this case, the person that falls in both events will go in this one. And this is Alicia. Alicia had B and E. Remember, that symbol means intersection, which we pronounce as end. So Alicia has both events B and E. She falls in that category. The next one is B union E. So B or E. Event B or event E. And this is going to be everybody in the circles. You just write everybody's name down that is in the Venn diagram. So we have Ellis, Alicia, Brysa, and Steve. Not Don, because Don is not in the Venn diagram. And then the complement of B, put down here, squeezing them in here. So we want everything that isn't B. So who fell into category B was Ellis and Alicia. So we are going to write Brysa and Steve in this one. And then we have our last one is the complement of B or E. So that means anyone that falls outside of the union. And the only person that is Don. So event B or event E, the only person that's not inside our Venn diagram is Don. So he would be the event. When we describe, as we're doing that list of outcomes, the only outcome for that situation is Don. Now, I went through that pretty quick because you only get 15 minutes on this, so I'm running out of time. It looks good. The Venn diagram helps organize the information, and you will see problems with Venn diagrams as well. So get familiar with those, and that is good. That's it.